Okay. Good afternoon, students. In the last class, we discussed about the preparation and the properties of potassium trichromate. Today, we are going to study about the preparation and properties of preparation and properties of KMnO4, that is potassium permanganate. Okay, students. So in that preparation, so many types are there. Laboratory method is there, commercial method is there, that is industrial method, and the common industrial method is there. Okay, industrial, commercial as well as laboratory. Okay, we'll discuss one by one. So first is the preparation of and the properties of KMnO4. In that we will study first preparation. Okay, so yes, students, in this preparation, I told you this is very important for 3 marks, right? That is question number 23. Correct? This is yesterday also I told the preparation of potassium dichromate and this potassium permanganate. Those are very important for 3 marks. And the question number 23 is either this preparation of KMnO4 or preparation of K2Cr2O7. Okay. So here the preparation takes place in 2 steps. So what is the preparation method? I write process or method, you understand? Okay. MnO2O, manganese oxide and magnetite. So this term MnO2O is fused with alkali, strong alkali like NaOH or KOH in the presence of oxidizing agent that is KNO3. Okay, gives green color potassium manganate solution, which is further acidified with sulfuric acid gives potassium permanganate. So listen, students, this is the explanation for the preparation of KMnO4 solution. So here what they said, the MnO2O is fused with alkali in presence of an oxidizing agent KNO3, then it forms what? Potassium manganate. Okay, this potassium manganate further acidified with sulfuric acid gives potassium permanganate. 2-step reaction will take place to that. So first what happens? This MnO2 reacts with alkali, gives in presence of KNO3 as an oxidizing agent. So oxidizing agent means here addition of oxygen will take place. Okay, so this changes to what? MnO4 2 minus. So this is times potassium is there, you may directly write 2K2MnO4 plus 2H2O. This is the balanced reaction. Okay, MnO2 plus 4KOH plus O2 gives rise to 2K2MnO4 plus 2H2O. This is what? Potassium manganate. This is called potassium manganate. So this potassium manganate, okay, is acidified with what? H2SO4 gives KMnO4 plus K2SO4 plus H2O. Okay, students, here this is 2 moles, here this one is 3 moles, this is 2 moles, this is 2 moles, this is 2 moles, H2O is there, that is also 2 moles. Okay, this is the reaction, and this one is what? Potassium permanganate. Potassium permanganate. So, this is the reaction, students. The preparation of potassium permanganate by using MnO2. So, you have to write this explanation and these two reactions in a balanced manner. You will get 3 marks. This is the very important preparation. So, if the has write the explain the preparation of KMnO4 for 3 marks. The question number 23, you have to write this one. Okay, so this is preparation of what? KMnO4. So what happens here? The MnO4 is fused with alkali. Okay, alkali means strong base. So in the presence of oxidizing agent KNO3 and gives a green color potassium manganate solution. Okay, this potassium manganate which is further fused with sulfuric acid gives potassium permanganate. These two reactions represents the above explanation. This is the preparation of potassium permanganate. This is one preparation. Okay, industrial. Okay, another one is there, that is commercial. I'll go with that. That is electrolysis of MnO2 in presence of oxidizing agent KNO3. So this is second type of preparation. So here what happens, students? First, this MnO2 in an electrolysis process fused with, first what happens? This is fused with KOH in presence of KNO3 means this MnO4 2 minus will form. So this is the one reaction. As I explained before, this MnO2 it changes to what? MnO4 2 minus. So in the second thing what happens? This MnO4 2 minus undergoes electrolysis. Okay, gives MnO4 minus. Okay, we have plus an electron. This is the electrolysis process. Here, the electrolysis process, first reaction taking place, Like this only, this MnO2 is fused with KOH and KNO2 it forms manganate ion. This manganate ion undergoes electrolysis and gives permanganate ion. This is another type. What is this? Electrolysis of MnO2 in presence of oxidizing agent under KNO3. First, when it is fused with, then it will form manganate. Manganate undergoes electrolysis gives permanganate. Okay. So next one is preparation, laboratory preparation. So in the laboratory preparation, what happens? This is mixed with thiosulfide ore. Okay, this will mix with thiosulfide ore. This is laboratory method. So in this laboratory method, what happens is this any Mn plus 2 compounds, it may be Mn, K2MnO4, whatever it may be. So Mn plus 2 compounds reacts with thiosulfide. Okay, that is in the aqueous solution. Gives what? Here it changes to MnO4 minus plus SO4 plus H minus. Okay, this is the reaction. If you want, so this is not H minus, this one is H plus. If you want to balance the reaction, students, this is 2 moles. Okay, this one is 5 moles, this one is 8 moles. So here 5 to 8 means 10 means 10 SO4. Here 2 MnO4, so remaining is 16 H plus. So this is the reaction. You may write it here directly. 10 SO4 2 minus plus 16 H plus. So this is the reaction. This is the laboratory reaction. If you take any Mn plus 2 compounds, if you have, if it is mixed with the thiosulfide, this thiosulfide is converted into what? Sulfate ore. So this is the reaction. This Mn plus 2 changes to its oxidation to how much? Plus 7. Plus 2 to plus 7. This is laboratory method. The methods which I explained, the electrolysis and this laboratory method is important towards neat orientation. Okay, for examination, for board examination purely, the first one, the preparation of potassium permanganate by using that MnO2 is very important. These two are important for what? Neat. Okay, so now we are going to study the structure of MnO4 2 minus and MnO4 minus manganate and permanganate ion. So listen students, this is manganate or manganate ion, right? MnO4 2 minus here oxygen, this is minus, this is minus, this is tetrametrally bonded. This is what? Manganate ion. Okay, if you take Mn, here O minus means any one of the oxygen atom should possess minus charge with the tetrametral geometry. This is the permanganate ion. Okay, in both the case, the bond angle is 109.5 degree as the angle of sp3 hybridization, because this is tetrahedral in shape. So tetrahedral shape bond angle is 109.5 bond length, sorry, bond angle. Okay, so this is structure of MnO4 minus and MnO4 minus. Okay, students, in this, as I told you, the preparation of first one is important. Along with that, the structure of MnO4 and MnO4 minus is important. But this they will never ask in the examination to write the structures. They simply ask how many single bonds are there, how many pi bonds are there, how many sigma bonds are there, and what is their bond angle and what is their shape. Like that, they are going to ask in the NEET or CT. Okay, so this is all about preparation and structure of MO. Now we come to what? Properties. Now we came to properties. So in the properties, we are going to study the chemical properties, that is basically oxidizing nature of this potassium permanganate. Okay, so here it what happens, this potassium permanganate solution in acidic medium MnO4 minus. Okay, if it is treated with acid, it changes to what? Mn plus 2. Okay. Okay, so this changes to Mn plus 2 plus H2O. And say first, here 4H2O, here 8H plus. This is an acid. If this MnO4 minus is treated with alkali, OH minus or H2O, then it changes to MnO2 plus here from plus 7 to changes to plus 4. So 3 electron exchange takes place. Here it will give H2O. How many H2O? Here it will take, here you will get OH minus. This will be taken as what? Alkali. So listen students, here 3 electron exchange takes place. 4 oxygens are there. Here MnO2 means 2 oxygen left. Here 3 oxygen means you simply write 3 OH minus. I will write 6 OH minus by writing here 2. 3. Okay, so this is the balanced reaction which we are going to observe in the alkaline medium and the acidic medium. So you are going to check here from plus 7 to plus 2, from plus 7 to plus 4. So in the basic medium, are you simply just rub this? You know the second reaction, that is what? MnO4 2 minus. So in presence of acid, changes to what? MnO4 minus. Correct? You see this reaction just before reaction would be like MnO2. So if you reverse this, students, plus H2O is there, then what happens? In the acidic medium forward reaction, this manganate changes to permanganate and Mn. So here in the alkaline medium, again this MnO4 minus changes to MnO4 2 minus. That's what I am going to tell here. So remember one thing, in acidic medium, another one is the Mn plus 7 changes to Mn plus 2 state. In basic or alkaline medium, Mn plus plus 7 changes to Mn plus 4. You remember this thing? That is more enough to you people. Okay, while solving the reactions, I will explain how this MnO4 and MnO4 2 minus and MnO4 minus takes place in acidic as well as alkaline medium. We will discuss some questions, some balanced chemical reaction, you will understand. Okay, so first one, we discuss and write it clearly, students, very important. Oxidizing nature of KMnO4 in acidic medium. So first I will write the general reaction, that is K, simply write ionic reaction, MnO4 minus in presence of H plus gives rise to what? Mn plus 2 plus 4H2O. If 4H2O is there, then this is 8H plus. So this is what? The acidic reaction of the ionic reaction in the acidic medium of the KMnO4. So students, here how many electron change takes place? Here plus 7 is there, here plus 2 is there. Then the number of electron exchange takes place is 5 electrons. Correct? Plus 7 to plus 2 means 5 electron exchange takes place. So here what happens? Here gain of electron takes place means the gain of electron means reduction. The species which undergoes reduction causes oxidation, or it oxidizes other elements by made them to lose electrons. In that I will write, in the last class I said, like potassium dichromate, it also changes I minus to I2. Okay, next sulfide to sulfur. Next oxalate to CO2. Correct? And another one, Fe plus 2 to Fe plus 3. Okay, so these are all the reaction I am going to write here now. So first one, I minus to I2. Okay, so here I will write this reacts with I minus, changes to I2 plus 2 electron to balance this one. From 1 I, 1 electron will lose, here 2 I is there, so 2 electron will lose. So listen students, we have to do what? Balancing the number of electrons. Here 5 is there, here 2 is there, they cannot be divisible. So this will multiply by 2, this will multiply by 5. So the overall reaction comes to what? That is multiplied by 2 means 2MnO4 minus plus 16H plus 10 electron gives rise to 2Mn plus 2 plus 8H2O. This is first reaction because this is multiplied by 2. Second one, 10I minus changes to 5I2 plus 10 electron. So in both the cases, both sides, the electrons are equal. So then this is 2MnO4 minus plus 16H plus 10I minus gives rise to what? 2Mn plus 2 plus 5I2 plus H2. So this is the balanced equation or ionic equation in which when this KMnO4 is there and it is treated with iodide, then in presence of acid it oxidizes this I minus to I2. Here the oxidation state of iodine is -1, here it is 0. -1 to 0 means loss of electron takes place, that is oxidation. This KMnO4 helps to oxidize this I minus to I2 by accepting an electron to change its oxidation from +7 to +2. Okay, so this is one reaction. Similarly, if we consider this sulfide ore means, instead of this we have to take yes 2 minus. This is sulfur and 2 electron. So same, this is multiplied by 5, this is multiplied by 2. Instead of this we have to take iodine sulfur 2 minus. Here we will get how many times? This is 5 times. This is 5 times sulfur plus 10 electrons. Then here also we will get 5 iron. 5 yes 2 minus. Here 5 yes. Only this thing will change, students. Only the number of electron exchange takes place here. Correct? So similarly, for this, if you consider oxalate ion, okay, I am writing clearly because oxalate ion, this is very important. So I am writing it completely. Here, oxalate ion means COO twice 2 minus changes to CO2. Okay, here COOH twice is there, that means it changes to CO2 plus H2O. Correct? So here what happens? This is 2CO2. That's the 2CO2. So here students, listen. If you calculate the oxidation state of COO here and calculate here, so 1 into carbon plus 2 into oxygen with the minus 2 charge. Carbon we have to check 2 into minus 2, then the charge is minus 2. Here 2 carbons are there because C2O4 2 carbon, correct? So here 2 carbon minus 4 is equal to minus 2. 2 carbon is equal to plus 2. So carbon is in okay, plus 2 of carbon is in plus 1 oxidation state. So in here CO2 carbon is in plus 4 oxidation state. Sorry. Here 4 oxygen, not 2. Then it is minus 8. Then we will get plus 6. Then this is plus 3 charge. Here in C2, this oxalate ion, it is in plus 3 star. In CO2, it is in plus 4 state. So here the electron changes from plus 4, plus 3 to plus 4 means 1 electron. But here 2 carbon is there, so 2 electron. From 1 carbon, 1 electron. From plus 3 to plus 4. From 2 carbon, 2 electrons. So again we have to multiply this with 5. We will get students here. This is 5 COO 2 minus gives rise to 10 CO2 plus 10 electrons. So this will get cancelled. Then we will get 2 MnO4 minus plus 16H plus 5 COO 2 minus gives rise to 2 Mn plus 2 plus 10 CO2 plus 8 H2O. So students, this type of reactions you already studied in the first year, that is redox reaction. Again we are doing the same thing. Okay. So next, if we compare this equation for iron. So for iron what happens? Listen. How iron changes? Iron changes from plus 2 oxidations to iron plus 3 with 1 electron. So here 5 electrons is there, here 1 electron is there, this is multiplied by 1, this is multiplied by 5. Okay, if this equation is multiplied by 1, it remains as it is, and this is multiplied by 5 means this is 5 Fe plus 2 changes to 5 Fe plus 3 plus 5 electron. So here electrons gets cancelled. Correct? So then here what happens? This 2MnO4 minus plus 5Fe plus 2 plus 16H plus changes to how much? This is not 16. This remains as it is, as I told you. 8. This one is Mn. This one is 4. This is 8H plus, because as I told you students, for this iron that is multiplied by 1 means MnO4 minus 8H plus 5 electron, Mn plus 2 plus 4H2. This one is multiplied by 5 means 5Fe2 plus 5Fe3 plus 5 electron. These two gets cancelled. Then we will get MnO4 minus 5Fe plus this 8H plus into Mn plus 2 plus 5Fe plus 3 plus 4H2O. So this is the reaction. This is the way to write the balanced chemical reaction, which shows the oxidizing nature of what? This NO4. Okay. So in all these students, in the acidic medium, the MnO4 minus changes to what? Mn plus 2. Okay. So in acidic medium, manganese. So in potassium permanganate or any permanganate ion loses 5 electron to attain its plus 2 oxidation state. Okay, it gains, not loses. Okay, so the next one is oxidizing nature of this oxidizing nature KMnO4 in alkaline medium. Okay, remember this. So here what happens, students? First I will write the components here. What it will do? So it changes I minus 2, I O3 minus. It changes I minus 2, I O3 minus. And next it changes thiosulfate S2O3 2 minus 2 SO4 2 minus. Okay. So next it changes Mn plus 2 to Mn plus 4. So here what happens? The oxidation state increases. Again the same thing. Oxidation nature means it used to get thin. So students here again I will write the general equation for that. In MnO4 minus, in presence of alkali, changes to what? MnO2. Okay, as I told you, it changes from plus 2 oxidations to what? Plus 4 oxidation state in OH minus. This is OH minus. So here we have to do what? This one is 4OH minus. Now it is balanced. 1 Mn, 4 plus 2, 6 oxygen, 2 plus 4, 6 oxygen, and 4, 5 hydrogen. So this is the balanced equation of oxidizing nature of KMnO4 in alkaline medium. Okay. So here what happens? If this I minus is treated with here, how many electron exchange takes place? Gains here from plus 7 to plus 4 means 3 electron. 3 electrons. Correct? So here we have to write this I minus to I3 minus. I minus is there. This I O3 minus is there. Here addition of oxygen takes place as well as this iodine charge is also. This is minus 7 to how much? Plus 7. At the same time, addition of oxygen also takes place. So if you have to write here, students, the entire reaction becomes how much? This MnO4 minus, this is 2 moles, plus H2O 2, 4 moles, gives rise to MnO2 plus 8OH minus plus IO3 minus, here I minus. So this is the balanced chemical equation for the given reaction. So if you balance that, you simply take this one means you get the correct answer also. Okay, this is correct. This is the balanced equation. So students, here whatever you have to remember, this iodide is changes to what? Iodate. Iodide is changes to what? Iodate. Okay. So this is one. If it is an acidic medium, what happens? This iodine will change us to, this iodide will change us to iodine. But here iodide to iodate. So next one is sulfate. If you want to write the reaction for sulfate means, so this will give 8 MnO4 minus plus 3S2O8 3 minus 2 minus plus 8H2O. So H2O gives rise to what? MnO2 plus 6SO4 2 minus plus H minus. So this is the answer. Okay. So this is what? 8 MnO4 is reaction 3S2O8 2 minus and H2O gives rise to SMnO2 plus 6SO4 2 minus plus OH minus. Here thiosulfide is changes to what? Sulfate. Okay. Here the oxidation state is plus 3, here the oxidation state is plus 6. Here it is plus 4, here it is plus 6. So this is you may easily see here. 8 means minus 8 minus 16. So here 2 means plus 2 means 14 divided by 2 means plus 7. Here it is plus 6. So gain of the electron takes place here. Okay. So students, next one, last one, this MnO4 minus reacts with Mn plus 2 compounds means in presence of H2O changes to 2MnO2 plus H minus. This is also a reaction. Okay. Here. So here is plus 7. This permanganate ion reacts with plus 2 compound of Mn means it changes to equal to plus 4 state. So this is all about the oxidizing nature of KMnO4 in alkaline medium. You have to remember only one thing in alkaline medium. So these will they never ask students. You just remember what is the oxidation change takes place in what? The alkaline medium as well as acidic medium. So in the acidic medium, the oxidation state of Mn changes from plus 7 to plus 2. In alkaline medium, the oxidation state of Mn changes from plus 7 to plus 4. This KMnO4 is also used for what? Quantitative analysis or laboratory methods for a quantitative analysis. Like for example, by taking this KMnO4 as a titrant, we will react with FES, oxalic acid or any other, then that we will came to know how many moles of or how many ml of K2Cr2O7 0.1 molar consumes, how many moles of FeSO4. From that we will calculate what is the molarity of the respective Okay, students, in the last class, I asked you one question. As today I am explaining the name metaphor concept means I will tell you. So listen, if you consider this KMnO4, it is a dark purple color crystals. Okay, dark purple color crystals. So why they are so dark? So listen, even so this is KMnO4 is there. So in this Mn is in 1 into potassium plus 1 into Mn plus 4 into oxygen plus 4 into oxygen. This one is Mn, this one is potassium. So it is plus 1 plus 6 minus 8 is equal to 0, x minus 7 is equal to 0, x is equal to plus 7. So here manganese is in plus 7 oxidation. So listen, if we consider the atomic number of manganese, that is plus 4, argon 3d5, 4 is 0, 4 is 2. So Mn plus 7 means it is argon configuration only, that is 3d also 0, 4s also 0. So here students, if we consider the box diagram, there is no unpaired electron. Okay, there is no electron, 3d orbital is 0, 4s orbital is also 0. Even though there is no electrons in the d subshell and the s subshell, there is no unpaired electron. This is purple in color. Why? So this is the very important question as we see in the view of NEET. Okay. So NEET view, this is very important. Why? Because students, this is a somewhat out of syllabus question. Why? Because, so listen, here KMnO4 means oxygen atom is there, potassium is in plus 1 oxidation state, it loses its electron, okay, never give electron to manganese. But here, oxygen atom is there, so this oxygen atom has lone pair electron, correct? So the lone pair electron present in this oxygen enter this p orbital. Okay, they enter this d orbital. So these electrons results in the color of the KMnO4 solution. Okay, so this is very important. Why? Even though Mn is present in the plus 7 oxidation state, it is present in a dark purple color in KMnO4 crystal. Why? Because the electron from oxygen is transferred to this d orbital. The d orbital electron shows dd transition. Due to that dd transition, we will get purple color, and this theory is called as electron transfer theory. So why I am telling this students, it is not important for board orientation also, but why I am telling this, I so many times I solved the questions based on this topic. Why the manganese is in purple color even it is in a plus 7 oxidation state in KMnO4 salt. Similarly for dichromate also, K2Cr2O7, Cr is in plus 6 oxidation state, then also it is orange in color. Why it is orange in color? Because from the electrons from oxygen will enter into this d orbital, the lone pair of electrons which present on oxygen. So that results in what? Color of the respective metals. Okay, so this is all about D and F block elements, the preparation and the properties. So in that properties they may written as students that preparation is very important. As I told you, question number 23 and question number 24 is from D and F block. This is always preparation of K2Cr2O7 and KMnO4. This is based on properties which we were discussed like ionization energy, atomic size, ionic size, okay, magnetic property, catalytic property, all are comes under this question number 24. This is always 2 plus 1. Okay, this is always 2 plus 1. Then as magnetic property, catalytic property, whatever there. So here 2 marks is properties are them as what are lanthanides and actinides are the difference between lanthanide and actinide and also lanthanide contraction. These are important for 3 months. So in the next class, I am going to tell you about the F block elements while I am explaining that what are these, what are the difference between lanthanide and actinide contraction, what is the difference between lanthanides and actinides, how they react. I will explain all the things in the next class. Thank you.